Still on the course Programming in Java, I welcome you to the concept of polymorphism with inheritance hierarchies. I expect that at the end of this lecture, you should be able to discuss the concept of polymorphism and distinguish between abstract and concrete classes. Polymorphism enables you to write programs that process objects that share the same superclass, either directly or indirectly, as if they are all objects of the superclass. It enables you to program in the general rather than program in the specific. Consider this example of polymorphism. Suppose we create a program that simulates the movement of several types of animals for a biological study. Classes of fish, frog, and bird represent the types of animals under investigation. Imagine that each class extends superclass animal, which contains a method move and maintains an animal's current location as XY coordinates. Each subclass implements method move. To simulate the animal's movement, the program sends each object the same message once per second. Each specific type of animal responds to a move message in its own way. A fish might swim 3 feet, a frog might jump 5 feet, and a bird might fly 10 feet. Each object knows how to modify its XY coordinates appropriately for its specific type of movement. Relying on each object to know how to do the right thing in response to the same method call is the key concept of polymorphism. Sometimes it is useful to declare classes called abstract classes for which you never intend to create objects because they are only used as superclasses in inheritance hierarchies. We refer to them as abstract superclasses. These classes cannot be used to instantiate objects because abstract classes are incomplete. Subclasses must declare the missing pieces to become concrete classes from which you can instantiate objects. What is the purpose of abstract classes? Its purpose is to provide an appropriate superclass from which other classes can inherit and thus share a common design. You make a class abstract by declaring it with keyword abstract. On the other hand, classes that can be used to instantiate objects are called concrete classes. Such classes provide implementations of every method they declare. Some of the implementations can be inherited. For example, we could derive concrete class circle, square, and triangle from abstract superclass two-dimensional shape. Similarly, we could derive concrete class sphere, cube, and tetrahedron from abstract superclass three-dimensional shape. In summary, polymorphism is the ability to process objects that share the same superclass in a class hierarchy as if they are all objects of the superclass. Polymorphism makes systems extensible and maintainable. Abstract classes allow you to provide an appropriate superclass from which other class can inherit. It can declare abstract methods that each subclass must implement to become a concrete class, and a program can use variables of an abstract class to invoke the subclasses implementations of abstract methods in polymorphic manner. Also, declaring and implementing an interface is another way to achieve polymorphic behavior. I will see you in the next lecture where we will discuss Integrated Development Environment, IDE, which is used in developing software applications.